So let's review what we've learned about trig ratios and relationships. So trig functions are the relationships among various sides in right triangles. Each possible ratio between sides, the length of one side divided by another of a right triangle, is a trigonometric ratio. We can find trig ratios given a triangle, given a point, or an angle on a coordinate plane. There are 6 trig ratios, the 3 primary ratios plus their reciprocals. In this video, we're going to identify the trig ratios given a right triangle or given a point. All right, in the next video, we'll look at an angle on a coordinate plane. So you have all of this in your notes. Consider a right triangle, triangle ABC, with the right angle at C and with lengths A, B, and C, as in the figure on the right. For the acute angle A, we call the leg BC its opposite side, and call the leg AC its adjacent side. Recall that the hypotenuse of a triangle is the side AB. The ratios of the sides of the right triangle occur often enough in practical applications to warrant their own names. So we define the 6 trigonometric functions of A as follows. All right, so I have A listed and I have B listed. So if we switch the angle of reference from A to B, then side AC becomes the opposite side and side BC becomes the adjacent side. And because in practice it's kind of a pain to write all the sides with 2 letters when we're trying to solve equations, right, and write ratios, we have another way to write the sides of the triangle. So angles are written in capital letters, sides are written in lowercase letters, and they're named for the angle opposite. Right? So side B is opposite angle B, side A is opposite angle A, and side C is opposite angle C. So if we're looking from A's perspective, sine A, which is the opposite over the hypotenuse, is going to be side A over side C. Cosine A, so from angle A's perspective, is going to be adjacent over hypotenuse, and in this case, adjacent is side B over the hypotenuse, which is side C. The tangent of angle A is the opposite side over the adjacent side, which is going to be A over B. Cosecant is the reciprocal of sine, so it's going to be hypotenuse over adjacent, or for this triangle, C over A. Secant is a reciprocal of cosine, which is hypotenuse over adjacent, so for this triangle it's C over B. And the cotangent is the reciprocal of tangent, so it's adjacent side over opposite side, so for this triangle is B over A. All right, just a little review of our 6 trig ratios and which sides each one uses. So now we have a triangle here. We want to find the values of the 6 trigonometric functions for angle theta. Notice we only have 2 sides of the triangle, right? So we could only write 2 ratios unless we find the third side, right? And to find the third side, if you've got 2 sides of a right triangle, of course we're going to use Pythagorean theorem. So our first step is to use Pythagorean theorem to find the third side in the triangle. Right, and this is the hypotenuse. Right, so don't automatically put, I have students who automatically will just put whatever 2 sides they're given as the 2 legs and assume the missing is always the hypotenuse equals x squared. Nope, this x here, our unknown, is a leg. So it's going to be 12 squared plus x squared equals 16 squared. Make sure the hypotenuse is isolated. So we have 144 plus x squared equals 256. We're going to solve for x squared, which means we'll subtract 144 from both sides. So x squared equals 112. That is not a perfect square, so we will simplify the radical if possible. I'll just put that over here. So simplify, radical, if possible. All right, so we want to take the square root of both sides, but we only want the principal root because this is a measurement. All right, so I need to give myself a little bit more space. Something that divides evenly into 112. Well, 4 divides into 100. 4 divides into 12. I feel kind of confident that it might divide into 112. Let's check it out. So 11 divided by 4 is going to be 2 with 3 leftovers. And so that means 32. And 4 divides into 32 8 times. 28 is divisible by 4. It's going to be 4 times 7. So that means 1 4 comes out, 1 4 goes away. So x is equal to 4 square roots of 7. All right, so that's our missing side here. So now step number 2. Is just to, where's my 2? Identify the 6 trig ratios. And I'm going to put this over here. And I'm not going to write, I'm going to, well, I think I've got enough room. I'll just remind us of what sides we use. All right, so sine theta is the opposite over hypotenuse. So that's going to be 4 square roots of 7 divided by 16. And don't forget to, on the identifying the 6 trig ratios, simplify and rationalize if possible. And by the way, this is in your notes. So the 4 and the 16 reduce, right? Both divisible by 4. So that's going to be 1 and 4. So this is going to be equal to, let me see if I can, now I'm regretting putting the opposite over hypotenuse. There, I think now I still have enough space. So it's going to be the square root of 7 divided by 4. All right, now let's find cosine. Theta, which is adjacent over hypotenuse. Adjacent side is 12, right? Oh, you know what? Let's label our sides. I almost forgot. So this is opposite. This is adjacent. And then we have hypotenuse. Always a good idea to label the sides to help you identify. All right, so we have adjacent is 12 divided by 16. That's going to reduce, they're both divisible by 4. It's going to reduce to 3/4. Let's find the tangent ratio. All right, tangent is opposite over adjacent. So the opposite side is 4 square roots of 7. I'm not going to have enough room to reduce. The adjacent side is 12. And those are both divisible by 4. Right? 4 divided by 4 is 1. 12 divided by 4 is 3. So that's going to be the square root of 7 divided by 3. Now let's find, actually I'm going to use the same colors for the reciprocals. So let's identify cosecant theta, which is just the reciprocal of sine. So now it's hypotenuse over opposite. So that's going to be 16. Right? Hypotenuse is 16. 16 divided by 4 square roots of 7. We can reduce, and we're going to have to rationalize. And I'm just going to move this over slightly. Right, so we can reduce 16 and 4. That's going to be a 1 and a 4. And that's going to be now 4 square roots of 7 divided by 7, right? Because square root of 7 times the square root of 7 is the square root of 49. What's the square root of 49? It's just 7, right? So rationalizing is pretty easy when you're dealing with square roots. Secant is the reciprocal of cosine, so it's hypotenuse, over adjacent, which is going to be 16 divided by 12. Both of those are divisible by 4, so that's going to be 4/3. And finally, we have cotangent, which is the reciprocal of tangent, and that is adjacent over opposite. Right? The adjacent side is 12. The opposite is 4 square roots of 7. Right? We're going to have to reduce and rationalize. So the 12 and the 4, that will reduce to 1 and 3. So we have 3 square roots of 7 divided by 7. And there we go. We've identified our 6 trig ratios. And it's that easy. Pythagorean theorem, right? And then really this is not much different than when you were in geometry and you identified the trig ratios for a triangle. You just have 3 more ratios. And they're just the reciprocals of the primary ones. Okay? So this is very similar to something we did in geometry, identifying ratios, identifying one trig ratio given another trig ratio. We haven't done this yet in this class. It's going to be the same steps, except we have more trig ratios to work with. We have 6 instead of 3. But other than that, it's going to be very similar to something we did last year. And the one thing you have to remember is that trig ratios tell you 2 sides of a triangle. That's all a trig ratio is. So solving when we are given a trig ratio. If we are given the sine ratio, we know 2 sides of a triangle. We know the opposite side, and we know the hypotenuse. Right? So now to identify a given trig ratio, we're going to follow these steps. So the first thing we're going to do is we're going to draw a triangle. A right triangle, and specifically, this right triangle is just going to be a place that we can list our information. All right, so we're going to mark the reference angle. It's going to be either one of the acute angles. It doesn't matter. I have a tendency to always mark that one. I have a tendency to have all my triangles look identical and always mark the angle in the bottom there. It doesn't matter which of the acute angles we mark, right? But when we do decide on an angle, that's going to tell us which is the opposite side and which is the adjacent and which is the hypotenuse. And all this is a way for us to list our information. Right, so we are given sine theta is 24 over 25. That means the opposite side is 24. The hypotenuse is 25. What are we looking for? We're looking for the adjacent side. How are we going to find the adjacent side? We're going to use Pythagorean theorem to find that third side. All right, so we are missing the adjacent side. Right, so let's use Pythagorean theorem to find it. Right, so we have, and so this is, let's call it x. Right, and so now we're looking for our x here is a leg again. Right, so it's going to be 24 squared plus x squared equals 25 squared. Make sure it's the hypotenuse, that's always isolated, not necessarily the missing value, unless your missing value is the hypotenuse. All right, so 24 squared is 576. 25 squared is 625. If we subtract 576 from both sides, we get x squared equals 49. And we only want the principal solution. Now, if we were solving an equation, just any old quadratic equation, we would have 2 solutions, right? 7 and negative 7. What's the length of negative 7? Right? That has no meaning, right? You can't give me something that's negative 7 inches, right? So because this is specifically tied to length, we want the principal root only. Right? So we'll take the square root of both sides. And this is a perfect square, so x is 7. We have found our missing side. And now we want to identify the requested ratio, rationalize, simplify if necessary. Now our requested ratio got erased when I erased the page because I wrote it down. So I'm going to, and it's going to be so on every one of these. I forgot I accidentally erased my requested ratio. I forgot to make sure it stayed. I remember to save the given ratio, but I forgot to save the requested ratio. So I'm just going to request it now, because it could be anything. We could find, now that we have three sides of a triangle, we can find any ratio at all, right? Now, if I asked for cosecant, by the way, we wouldn't even need to find the third side in a triangle, because cosecant is just the reciprocal of sine. So obviously I'm not going to ask for that. I'm going to ask for cotangent. That's going to be my requested. And why? Because I picked that one out. So cotangent, remember, uses the adjacent over the opposite. The adjacent side is what we just found, right? Its adjacent side is 7. And the opposite side we got from our sine ratio, that was 24. So our answer is just 7 divided by 24. And we are done. There's nothing to reduce, and there's nothing to rationalize. Let's try another one. And this time I'm going to write down the ratio, what we're going to find before we get started. I think I have 3 of these. So here we're given tangent. So let's find secant. Right? We'll find that. And actually, so this doesn't disappear again. Oops. Well, I was going to lock it, but apparently that's just not possible. But if I come over here to the mouse, we'll lock it in place. We'll never lose it again. All right, so we're going to think about what sides we have when we have tangent. We're given a tangent ratio. That means we know 2 sides in a right triangle, because that's all a trig ratio is. A trig ratio tells you 2 sides of a triangle. If it's tangent, we're told the opposite and the adjacent. Here's our right triangle. So step 1 is to draw a triangle, mark the reference angle, and label the sides based on the triangle. And that is just to organize your information. All right, so I like to have this one. I don't know. I'm just a creature of habit, I guess. So this is the opposite, this is the adjacent, and this is the hypotenuse. We know the opposite side, that's 5. We know the adjacent side, that's 3. So for all of you who thought this might be a Pythagorean triple, a 3, 4, 5, well, 4 cannot be the hypotenuse. We're going to look for the hypotenuse. All right, so that means we're going to use Pythagorean theorem. We're missing the hypotenuse. Well, you know, I should have chose something where we'd have to rationalize, and we're not going to have to rationalize. Maybe I should have chosen secant. Maybe I should have chosen sine or cosine. Yeah, you know what? Let's choose cosine instead. Because we should get some practice rationalizing. Oops. And I'm just going to lock that in place because I like my choice. All right. We're missing the hypotenuse. Let's use Pythagorean theorem to find it. So we have 3 squared plus 5 squared. Our hypotenuse now is the unknown, equals x squared. So that's 9 plus 25 equals x squared. We only want the principal root, so 34 equals x squared. Square root of 34 equals x. That does not simplify because it's 2 times 17, and both of those are prime numbers, and they don't match. Right? So we want to find the cosine ratio. Remember, cosine is adjacent over hypotenuse, and we will rationalize if necessary. We won't have to reduce, but we will have to rationalize. So our cosine ratio, the adjacent is 3. The hypotenuse is the square root of 34. So that means we're going to multiply numerator and denominator by the square root of 34, and it's as simply as 3 square roots of 34 divided by 34. Right? It's really not too hard to rationalize, because you're simply, when you're dealing with square root, you've got square root of 34 times the square root of 34. You got 2 that match. 1 comes out, 1 goes away. You just have 34. All right, let's do one more. All right, so this time we are given secant. Let's find sine. And since I like my choice, I think, let's save it. So just in case I erase the page again, I won't lose it. All right, so number trig ratio just tells you 2 sides of a triangle. If we're given secant, secant is the reciprocal of cosine. We're given the hypotenuse and the adjacent. Here's our right triangle. Here's our angle of reference. We're going to label the right triangle based on our angles. So if I put my angle of reference there, it means this is the opposite, this is the adjacent, and this is the hypotenuse. And if you like where I put the angle of reference, then you do the same thing. It's going to be one of the 2 acute angles, and it just helps us organize information. So we're given the adjacent, that's 5. We're given the hypotenuse, that's the square root of 35. By the way, that doesn't simplify because the factors are 7 and 5. They're both prime, and they don't match. All right, so we're missing the opposite side. All right, so we're going to use Pythagorean theorem to find that missing third side. So we have, that's a leg, so we have 5 squared plus x squared equals the square root of 35 squared. So that's going to be 25 plus x squared equals square root of 35 square and square root cancel. That's just going to be 35. So that means that x squared is 10, and x is going to be the square root of 10. And of course, we only want the positive principal root. So now we can identify the ratio. So we have, number sine is opposite over hypotenuse. Actually, I should have seen which ones we didn't use. Well, I could have used, the only one I wouldn't want to use in this problem here is I would not want to use cosine because it's just a reciprocal. But I could have used cosecant. But sine will be fine. I think we used cosecant on one of the problems anyway. All right, so sine theta is opposite over hypotenuse. The opposite side, oh, we didn't write it in here, is the square root of 10. The hypotenuse is the square root of 35. Now this is an interesting little problem because a quotient of radicals is the same as the radical of the quotient. So this is the same as this. Well, that could be reduced. Those are both divisible by 5. Let's simplify first. Okay. Now, it would not be wrong if we multiplied by the square root of 35 over the square root of 35, and then we'd have 350, and then we'd have to reduce. It would be easier if we reduce first. Right? I think in this problem, if you've got 2 radicals and they have a common factor, write it as one radical, reduce, and then rationalize. Right? So this would reduce to 2/7. That's the same as the square root of 2 divided by the square root of 7. To rationalize, we'll just multiply by the square root of 7 over the square root of 7. Square root of 2 times the square root of 7 is the square root of 14. Square root of 7 times the square root of 7 is the square root of 49, which is just 7. Now these do not reduce, right? Because a radical and a number not under a radical can never reduce. Number reduces with number, radical reduces with radical. All right? And so it's that easy. And guess what? You can now do every problem in the homework because I have now covered every single skill. This was the last skill. Right? And really, it was just a review of what we've done last year, just adding a little twist to it by including cotangent, cosecant, and secant. All right, so now let's find the trig ratios given a point. All right, so same thing, right? Except now we can, because the coordinate plane has signs, our trig ratios can have signs. Right? On a triangle, everything's positive, but on the coordinate plane, x can be negative and y can be negative. So we're going to find all 6 trig ratios given the point -4, -6. I have listed the steps here. If the steps are not in your notes, it might be a good idea to write them down, particularly if you have any trouble with this. So step number 1, to draw the triangle from a point. Let's first graph our point. We have the point -4, 6. I have, since my coordinate plane here didn't have any values on it, I have drawn some so I can draw a triangle. So there's the point, -4, 6. To draw the triangle from a point, go straight down to the x-axis and straight down to the origin. Never, ever, 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 never, never go to the y-axis. All right? The angle is, that says is, the angle is always against the origin. Here's our angle. All right? So we have always, 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 x on a coordinate plane, x is going to be the adjacent side. And always, always, always on the coordinate plane, y is going to be the opposite side. And this, of course, is our hypotenuse. That value that goes, that segment that goes from the point to the origin. All right, so we know what x is. X is -4. That's the adjacent side. We know what the opposite side is. That's 6. What we don't know is r. All right, so we're going to use Pythagorean theorem to find r, and as a reminder, r is always positive. So we have -4 squared plus 6 squared equals r squared. All right, if you took a square root of both sides, you have r. All right, so just another way. I can simplify it and then take a square root. I can take a square root of both sides first, right, which I've done over here. It's exactly the same answer. All right, so r is equal to the square root of 16 plus 36, which is the square root of 52, which simplifies, because 52 is 4 times 13, and 4 is a perfect square. So r is going to be equal to 2 square roots of 13. We are always going to simplify the radical. So not only is r is always positive, don't forget we're going to simplify the radical if possible. All right, so now we have all 3 sides of our triangle. Let's find our ratios. And I don't think I'm going to write the opposite and hypotenuse adjacent out. I'm just going to put the ratios in there. I'll say which sides we use, but I'm not going to necessarily write them down. I think I'm going to run out of space here. So sine theta is opposite over hypotenuse. That's going to be 6 over 2 square roots of 13. We need to reduce, and we need to rationalize. So that's going to reduce. 6 divided by 2 is just 3. And then we'll multiply by the square root of 13 over the square root of 13. So that's going to give us 3 square roots of 13 divided by 13. And I was right. I would have ran out of space. All right, so now we want cosine theta, which is the adjacent over the hypotenuse. The adjacent side is -4. And of course, by the way, remember in the second quadrant that sine and its reciprocal cosecant are going to be positive because they do not use the adjacent side. All the other trig functions are going to be negative because they use the adjacent side. All right, so cosine theta is going to be adjacent, which is -4. divided by the hypotenuse, which is 2 square roots of 13. Again, we could reduce, right, divide them both by 2. So this would now be negative 2. Oh, that looks like 12. Hang on. It's too close to sign. If we move, oh, here. Let me just move that. There. Now I don't think we'll be confused. All right, so cosine theta is adjacent, which is negative 4, over hypotenuse, which is 2 square roots of 13. I'm not going to change colors like I did on the last one because I used the same color. It blended into the next problem. All right, so we can reduce that by 2. It's going to be 2 and 1. So we have in the numerator, and then we're going to have to rationalize. Multiply numerator and denominator by the square root of 13. In the numerator, we'll have negative 2 square roots of 13. We're expecting a negative answer. Square root of 13 times square root of 13 is simply 13. It's going to be the square root of 169. What's that? Just 13. All right, and then let's find tangent theta, which is the opposite side, which is 6 divided by the adjacent side. Nice and easy, that just reduces. Divide them both by 2, and we have, and I'm going to put the negative in the numerator, negative 3/2, and we're done. Right, now let's find the reciprocal of sine, which is cosecant. So now we have the hypotenuse divided by the opposite side, right, and we can just reduce that 2 and 6. That's now going to be the square root of 13 over 3, and we're done. And we have secant theta. All right, that's just the reciprocal of cosine, so 2 square roots of 13 divided by negative 4. We can reduce that by 2, so that's going to be square root of 13 divided by negative 2, or I can put the negative in the numerator. And then last but not least, cotangent, which is the reciprocal of tangent, is going to be negative 4 divided by 6, or negative 2/3. And that's it. We're done with this problem. We're going to do one more problem, right? And it's going to be super easy. It's still on the coordinate plane, but now it's going to be a quad angle. It's going to be right on the coordinate plane. Oh, I thought my little, so let me mark it. 1, 2, 3, 4, 5, 6, 7, 8. So now that got erased. All right, we want to find all 6 ratios for the point 0, negative 8. So here's our point, 0, negative 8. And no matter what the point is, we can find the trig ratios. You might be thinking, but what's the opposite side? What's the adjacent side? What's the hypotenuse? Well, the adjacent side is 0, because I said x is always the adjacent side. The opposite side is negative 8, because I said y is always the opposite side. How about the hypotenuse? Right? So remember that r squared is just equal to the adjacent side squared plus the opposite side squared. Right? The two legs. Right? Adjacent and opposite are always legs. Right? And then if I take the square root of both sides, I get r equals the square root of 0 squared plus negative 8 squared. Well, that's just 0 squared is 0. Negative 8 squared is 64. What's the square root of 64? Of course, it's 8. All right, so the distance between of that segment there, of course, is 8. We just have to have a vertical line. But distance is always positive, right? The x and y can be negative, but r will always be positive. So now we have all of our values. And you don't have to actually use Pythagorean theorem to solve for r. All right? As long as you recognize that it's just going to be that distance there. How long is the segment? That's 8 units long. It's 8. Right? So now let's find all of our trig ratios. So let's start with sine. Sine is opposite over hypotenuse, so that's going to be negative 8 divided by 8, and that's just negative 1. Now let's find, let me switch colors here. Cosine. Cosine is adjacent over hypotenuse, so that's going to be 0 over 8, and that's just 0. And now let's find tangent. Tangent is opposite over adjacent, so that's going to be negative 8 divided by 0. You can't divide by 0, that's undefined. Let's find the reciprocal of sine, which is cosecant. That's just the hypotenuse, which is 8, divided by the opposite, which is negative 8, and that's just negative 1. Now let's find secant, which is just the reciprocal of cosine. All right, so that's going to be the hypotenuse, which is 8, divided by the adjacent, which is 0. Oh, that's undefined. And then finally, let's find cotangent, which is the adjacent, which is 0, divided by the opposite, which is negative 8. And what's that equal? 0. So notice we got two values that are 0, two values that are negative 1, and two values that are undefined. And matter of fact, my light went off. And I'm waving my arms in the air trying to get the light to go on. I'm in the dark here. All right, so that's going to happen every time. You're either going to have, you're always going to have two values that are 1 or negative 1, two values that are 0, and two values that are undefined, depending upon which trig ratio you're finding. And is it the opposite that's 0, the adjacent that's 0, is the opposite or adjacent positive, or is the opposite adjacent negative, right? So here, if we were, instead of 0, negative 8, if we were 0, 8, then sine and cosecant would both be positive, but the others would still be 0 and undefined, because we, at some point, are going to have 0 in a numerator or 0 in a denominator, right? So that's the end of this podcast. Thanks for watching, and bye for now.